Thank you. So my talk is not about ClickHouse. I hope you already know what it is. Instead, I will just do some entertainment. I will build a small toy on top of ClickHouse, but you will help me. What for? Why to build a toy? First, it is useful for testing. You can try interesting options, you find unusual scenarios, and make the system better. Second reason, it was an internal contest in our company. So every employee in our company has to build a small demo application on top of ClickHouse. I will not tell you how many people finished this contest. I will only say that I did. And another reason is to play and to have fun. So, to build a toy, what do I need? I need some idea, I need a nice data set, and a way to visualize and analyze this data set. So, we need a data set, and we need an internet scale data set. I wanted to say web scale data set, but web scale sounds a little bit fishy. So, let's say internet scale data set. And how to get this data set? Well, we will get it from the internet. So, how to do it? Let's take it from DNS. So, basically, what we can do? If you have any domain, you can type this code like host google.com and get its IPv4 address, IPv6 address. You can also do the opposite. You can take the address, type host this address, and get some name. And for Google, you will get this name something.1e100.net. Interesting, why it is not google.com? Why 1e100? Yeah, exactly. It is just another line for Google. You can also use a more low-level tool, Gig. You specify some resolver address, you specify the host, the type of request, in this case is this A to get IPv4 address, and you will get the same. And you can do a reverse DNS request if you specify ETR address. And you have to encode the IPv4 address in a special way, so it works. Lot of work, it is trivial. Another question, so we have ETR records, but why ETR records even exist? Do you know what for? Why do we need ETR records? No idea. First, it is just for convenience. So when you do something like traceroute, instead of IP addresses, you will get some interesting names. For example, I have run this from my home, and probably this is my IP address. I have changed it a little, so don't worry. Another reason, sometimes it is needed to validate something, like to send emails. So when you send email from your IP address, the other server will check if it is not likely to be a spam. It will do a PCAN or a request and check that the host name will resolve to some IP address, and this IP address will resolve back to the same host name. So if you want to send email from your IP address, you will likely have to specify ETR records. Okay, nothing interesting so far. And I want to get the data set by scanning just all IPv4 address space. I want to perform reverse DNS requests on all IPv4 addresses. It is slightly less than 2 power in PowerShell IP addresses. So about 4 billion IPv4 addresses belong to the internet. And I want to scan all of them. How to do it? There are several tools already for this task, like MaxDNS or ADNS library. And these tools are fast, and this is the advantage. The disadvantage, if you will do it from your home, you will be blocked. And if I want to do it, how to do it? I don't want to be blocked by my ISP, so I will not do it from my home. I can do it from a data center, and I ask my friend to try this tool from his VPN. And my friend did it from DigitalOcean, and he was instantly blocked. I can do it in the cloud. I can create a machine in AWS. I can run this tool, but it is possible to do it in AWS, but you need to communicate it in advance. To communicate with their support engineers, and I'm an introvert. I don't want to communicate with anyone. I just want to get my data to run this tool to get a data set. So the question, which option did I choose? But what? No, not the last one. No, not transfer. I still have internet available. Another hypothesis. Work from my mobile phone and not from mobile phone of my friend. Any other options? Good to know. I did not choose that option. So actually none of the above. I choose to use a protocol named DNS over HTTPS. So let's take a look how DNS could work. DNS can work over UDP, it is unreliable, it is not secure, it can be, the responses can be changed by the provider and so on. It can work over TCP, it is also not secure. DNS can work over TLS, it is reliable, secure, but now you will have a complex handshake, and then you will have TLS handshake and so on. It can work with another protocol known as DNS Crypt, and DNS Crypt can work over TCP and over UDP, and it is rarely used, and also there is DNS over HTTPS. Probably I am confusing you a little. Okay, so what is DNS over HTTPS? You just do a request to some website. You can even do it from JavaScript, and it will return what you want. So it is pretty easy, like REST API. And there are plenty of resolvers available. One example is Cloudflare. In this case, you can just write IP address like 1111. It is the IP address of Cloudflare, or you can use Google DNS or HTTP or something, it will work. And in response, it looks like this. You can request it with curl, and it will return a JSON. You request a JSON, it will give you a JSON. So it is nice, and it is not visible for your ISP. So from your ISP, you just connect it to Cloudflare and do something. And hopefully you will not be blocked. Okay, as a bonus, you can use HTTP1, HTTP2, whatever. You can even pipeline multiple requests in a single connection. Actually not, okay, you can do multiple requests, and at least Cloudflare does not have any restrictions. At least I did not files or restrictions, and nevertheless, Cloudflare processing trillions of these requests every day. So if I do just 4 billion, they should not notice. It is just not in the ocean. Okay, let's prepare some table to write the results. The table will be simple. It will contain the date time of insertion time and everything that is returning as a string. And I will just pipe all the responses to this table to parse them later. Then I will write a script for math DNS scan. Sometimes I like to write this messy shell script just to avoid writing anything in Python. I don't even want to open some IDE. I just want to write a simple one-line shell script. It is one line. Okay, let's take a look at this script. So, first, I will prepare the list of IP addresses belonging to the internet. For this case, I will actually group them by 256. And for the remaining, I will enumerate all the networks. I will filter out some IP addresses not belonging to the internet, like 127 something. Here it is. I will prepare this triple of 3 bytes, and then I will pipe it to its out for parallel processing and generate 256 numbers, and then start compute and generate a command to call. This is just the preparation for the argument to call. And here is the URL of Cloudflare DNS over HTTP, and it will give the result, and I will immediately insert this result into ClickHouse. And here is the insert query. Okay, did you get everything? Perfect. Now let's run this script. I want to run this script. By the way, do you know how long did this script run? 2 hours. A couple of days. 1 night. Why not a day? Why not? Maybe I prefer the sleep. 4 billion of IP addresses. And I need 4 billion for this request. It's 10 without. So, good confidence, it is still running. Okay, I run this script and I get this. Okay, actually nothing but has happened, only some smell of burned insulation. But nevertheless, it finished. I ran it from a single machine and it took about 10 days. Who said a couple of days? Okay, I don't have gifts today for you, but you win. So, by doing with math DNS, it will be just a few hours. But I don't worry. I created a machine, I ran it, and it has run unattended. I forgot about it, I returned and it is running. No one complained, and I had my data set. But by the way, when it was running, I was curious. Maybe someone will notice that I'm doing this scan. And actually, almost every scan, massive scan on the internet can be detected by tools that are named internet telescopes. It's quite interesting thing. So internet telescope is like a bunch of addresses on the internet that are listening to every background traffic. And if you do a scan, you will hit one or many of the top addresses, and Internet telescopes will notice you. And there is a public tool named Gray Noise. It is like analytics on top of one of Internet telescopes. So I went to this tool and I typed DNS or HTTP, and I found that someone does scanning the internet at this moment of time, and I thought, like, I didn't notice it. But then I checked, and actually it was some other guy, so nothing to worry about. Okay, and actually I did not have to do it by myself, because there are often historical data sets for DNS scans, like Project Sonar, and hopefully you can download this data set and analyze it instead of doing it by yourself. But I want to do it by myself. Sorry. Okay, how does it look? 3.69 billion records and about 13 gigabytes. So it is like 4 bytes per record. And it is to store this JSON response as a string. So pretty good compression rate, but probably it could be better. If I check the sizes of columns, this JSON is 13 gigabytes compressed, almost 900 gigabytes uncompressed, and the ratio is 65 times. Not bad. But I want to analyze this data, and I don't want to keep this JSON as is. So I will extract everything that it contains, and it contains status, question, artwork, in some different method JSON. I want to transform it to just a few columns. So I will extract the IP address with some trickery, and also extract the host name. And I will filter out the record that doesn't contain a host name. And here is my table with structured data. It contains, basically right and the resolved domain. And I can check how big are the columns. So IP address is about 4 gigabytes. Domain is about 1.5 gigabytes. Pretty good. Again, pretty good. Let's check what I can get from this data set. So if I just do a select, it will show me like 1001 is equivalent to 1111. By the way, it is Cloudflare DNS resolver. Then I will get some Japanese stuff. By the way, can you guess what is the most popular TLD, top level domain? Any idea? Top level domain. .com. .net. Okay. You probably get all of it. What? Interesting. What is the domain name from 90s? Maybe .su? Actually .net. So you are right. Then .com. Then Japan for some reason, and Brazil. I don't know why. Another question. What is the most popular organization on the internet, where organization is like the second subdomain after top level domain? Good. Alpha is a good hypothesis, but it will not, most of the time, it will not show if you do a reverse DNS request. Any other hypothesis? Oh, yeah. No, the next like organization. So if government should be like some government organization, like central.gov. No?
It's usually called.
Yeah. Okay, I'm interested in real organizations like significant subdomain. Okay, one example is Google. Another? AWS.
YouTube?
Wikipedia. Okay, let's check. Yeah, it is AWS. Then Compass, then something strange, I don't know what it is. There are some interesting stuff like Telecom Italia. I don't know, right? Okay, what else can we get from this data set? Also, we can try to get all subdomains containing ClickHouse, and it is easy. Where domain like ClickHouse. And I'm getting a lot of interesting stuff. Probably some companies using ClickHouse. Yeah, like just Mono, what is just Mono? Or Creator API. Nice. A lot of good stuff. Let me scroll down. Great. Well, I already sent this list to our sales team. Okay. I'm so interested, so let me continue to continue to say repeat tell me down. Nice. Okay. But when I don't have to do it this way, I can use some service like Shodan.io. Shodan.io is like internet scans as a service. They did a lot of different scans for various open ports on the internet. And found like MySQL services open to the internet, Reddit services, MongoDB, Elastic services, and also ClickHouse. And they have found 23,000 and a half services running ClickHouse and accepting connections from the internet. Now this is hopefully just a small subset of ClickHouse services because by default it is secure. It is not like it was for Reddit or Mongo. By default ClickHouse does not listen to the internet. So maybe if you multiply by 10 or 100, you will get the total number of ClickHouse services. Okay, how to represent this dataset? I want to make it nice because I don't want to just do queries and get tables. I want nice pictures. How to do it? And I want to do something like this. This is the picture from 2006, map of the internet. It takes all IP addresses. It represents all IP addresses in the line, then continue to dent this line and continue until it will shift into this square. It is minus space shading curve. I will not explain what is space shading curve. I don't want to look like amateur mathematician, so let me just do these calculations and get the result. Another example is here. It is like internet scan, and every IP address that answered from a certain port will be like a pixel of this picture. I want a similar picture, but bigger. I want all IP addresses, and this picture is just too small. So let me draw a picture with ClickHouse. It is possible. I will do it with a small shell string containing just one comment. Almost one comment. So this command is ClickHouse client. Let me try to read it. I will specify the dimensions of my picture. It will be 4K. I will extract the subdomain, hash it, extract columns from the hash. Then I will get IP address as a number, and I will decode this number into two coordinates using this function. And this function is calculating more than space sharing curve. Then I will aggregate the columns by averaging them there. And by the way, how to get the picture. So, ClickHouse cannot render the picture by itself. But there is a special picture format named portable net, portable whatever, portable bitmap. And it contains just a text with one of the pixels representing the binary number. And I will just output numbers, and with a small t, I will convert this text to a PNG picture. Then let's take a look. It looks like this. What a nice picture. It is just amazing. I can take it, print it in a higher resolution, put it in a frame, and put it somewhere in my apartment. It is so nice. It contains so much depth in this picture. By the way, it is just 4K. I can go in. It is even nicer. I can zoom in even more, but actually 4K is not enough. I want a picture for all IP addresses. Now it will be 65K or 64K, depending how you will count. 65,000 horizontally, 65,000 vertically. That I can generate this picture with the same color. It will be maybe a gigabyte. I did it. It works. But when I open it in Firefox, it crashes. When I open it in Chrome, it crashes. I can only show it with GIMP, but it is not convenient. So what to do? I want this picture easily zoomable and so on. I will generate files. So I want to do something similar to Google Maps, where you can zoom and move interactively. So now I have to write some code in JavaScript. I don't like JavaScript, but sometimes I have to use it. So I went searching what library to use. There is one library named Leaflet, and another library named OpenCDragon. And my criteria of choosing JavaScript libraries is to choose a library with the less fancy name. So OpenCDragon sounds really like some fantastic creature. I don't want to use this JavaScript library, so I choose Leaflet. Okay, and the basic format for Leaflet is quite simple. You generate files like images with three numbers. The first number is zoom level, the second is index, horizontal index, and another is vertical index. And to generate it, I will write a simple script, shell script. So I will iterate by zoom level, and for every zoom level, I will iterate by offset by x, and then run the same script as before. And I will get something like this. These are tiles. And Here is my website. Let's take a look. Interesting use of your work. By the way, I did not check before this presentation. Wow, it worked. And I can zoom in. And I can zoom in even more. There is so much text in this picture. Let's take a look. It is so beautiful, isn't it? I like it so much. And even more, I can click on any place, like this. And when I click, it will automatically get the data from my database. Okay. By the way, also, do you know what is this wireless stuff under cursor? Let's take a look. It is so interesting. Can we get look at it? How do you know? It's our topic. But why this stuff has a little bit of broken pixels? Let's take a look by zooming into any of this. It is like a website posted on Amazon that decided to create a beta website for this IP address. These are different websites. So very interesting. Let me by the way, how to proceed back. I want to get back to high presentation. Okay, just play it to me. Okay, just a few more boring slides. So, every time I click on this picture, it generates a SQL query to ClickHouse. And it's quite easy to do from JavaScript because ClickHouse has a REST API out of the box. You just post the query, select query to HTTPS endpoint, and it will return your JSON, and you can get anything from the JSON quite easily. But please don't forget to define some restrictions and quotas. So you have to create a separate user, it has to be a default user, it has to have this add HTTP core header. If you are a front-end developer, you know what it is. If you are a back-end developer, don't worry. Just specify the statement and it will work. And you can specify some restrictions for the usage, like the max number of select queries, the max number of insert queries per some time frame. And it will be ready to accept any traffic. Okay, so what did we get? We implemented this nice tool. I spent a lot of, not a lot, like several days, and it was really interesting. And I invite you, don't be afraid. You can use ClickHouse for everything. You can find something interesting in the progress. You can find some creative ways to use the technology, and hopefully you will find a way to break something. And if you break something, it is always for good. If you break something, you can fix it and continue. The source code is available, so that's it. Thank you.
Thank you, Alexey. And now we have 4 minutes for questions. So, any questions so far? Or I can ask my question. So, thank you for a good story. And this story is about that you have a real case that you want to solve, and you surprisingly choose ClickHouse as a tool that you will use for the solution. Is there any case that you will decide not to use ClickHouse? Or it's useful for anything?
So for me, I probably will use ClickHouse and even abuse ClickHouse for any case because it is my job to abuse ClickHouse and to improve it. But for you, so there are multiple cases when you want to choose any other database. For example, if you want document database, what you will choose?
Can I say the proper name, right?
Well,
Should I name Mongo something and begin the end?
probably yes, you can use Mongo. If you don't, but it's not a show we use MongoDB. So yeah, if you want a relational database with transactions, you will supposedly will choose Postgres or MySQL, but I will choose ClickHouse because I want it.
Okay, and is there any top 5 unique usage of the ClickHouse? So the popular cases and the people think that ClickHouse is the best choice, but then facing with some issues.
Typical case when you write some events to ClickHouse, but also want to update every single event when something changes. When the best practice is to do something that is managed event sourcing or event history. When something changes, just write another event, like a change event. Don't modify the existing event. ClickHouse will accommodate all the data, even if there are a lot of changes, and you will get the history for free. You can analyze this history, and this is the best way.
Okay, thank you. One more question here.
Hello, my name is. Thank you for your speech. I wanted to ask you 2 questions. So the first one, if I get it right, you did this whole project more for educational information. Maybe you applied it for some business cases. Maybe you consider it best to collect all this information in time and build analytics of how top domain usage changes.
This is really interesting idea. First usage of this service is to find some companies using ClickHouse. And by the way, this really large companies because they have to own the IP address or at least have some reason to define a feature record even if they use it from AWS. So not many companies specify it, and actually there is no reason to specify feature records most of the time, but I also want to get some dynamics. So another idea is to just run it, leave it to run continuously, and we will get not 4 billion records, but maybe 3 million records, and it is even better.
Okay, the second question is that have you measured time for inserts in the table after you made the scan? Can you measure the select time of guessing the IP address? And will you consider trying maybe some of the ClickHouse engines like distributed tables to get the faster time of the querying? Or in that case, it's just not necessary?
It's a really small table, like several gigabytes. It's about nothing for ClickHouse. So just a single machine and that's it. And for insertion, it is also, it is not like 0, but several minutes and you will get the data into ClickHouse.